As discussed, we are going to look at combo base. That is, when we have a positive and a negative base, but the magnitude is same. What to do? See, the first thing is, let's try to expand negative 10 to the power of 5. So negative 10 to the power of 5 is nothing but negative 10 into negative 10 into negative 10 into negative 10 into one more negative 10. So the first question to you guys is, how many negatives are there? There are 5 negatives. So remember, when we multiply odd number of negative terms, what do you get? You get a negative. So this is nothing but negative 1 into 10 to the power of 5. So if I substitute in the question 10 to the power of 4 into negative 10 to the power of 5, I am looking at 10 to the power of 4 into negative 1 into 10 to the power of 5. So positive into positive is negative 1 into 10 to the power of 4 into 10 to the power of 5. Of course, you don't need to write so many steps. It's just for my satisfaction, I'm writing over here. So negative 1 into 10 to the power of, we can apply the power rule over here, exponential law, and we get this. So we have negative 1 into 10 to the power of 9. That's it. So if you think of, like, say, negative 10 to the power of 2 or 20 or 200, this is an even number, is it not? So 10 will be multiplied, negative 10 will be multiplied even number of times. So if I happen to multiply this 200 times, negative multiplied 200 times will give me positive, is it not? And this is 10 to the power of 200. That's it. Make sense? So whenever you see a negative base with even power, you'll get positive answer no matter what. But if I see a negative base with odd power, I see a negative 1 into the base to the power of odd, like the one we just saw now, right? We just saw that example. Quite logical. So don't mess it up. Think logically. Maths does not work just by memory. Actually, no subject works like that. But yes, it seems, if not, but in time we'll understand that most of the topic works with logic. Okay? Right? Now, the next question. We can see traditionally how should you look at it. We see that the base is different. Instead of telling it different, it's of opposite sign. That will be a better note, right? Base is of opposite sign. So we can make use of our idea about negative 6 to the power of 4. Since the power is even, so your answer will be positive 6 to the power of 4. So basically you're looking at 6 to the power of 4 into 6 to the power of 5 is 6 to the power of 9. 4 plus 5, 9. So you can directly write all of this. You got it? So point here is, if you understand the basic well, you will be able to do the numericals faster. Understand the basics. We have few more problems. My suggestion is what? Yes, pause the video and write on your own. So what you're looking at is negative 10 to the power of negative 4. This we didn't see till now, right? We just saw two different examples, but not something wherein you have power also negative and base also is negative. So what to do? The first thing actually we had to notice, the base is of opposite sign. It's both 10, but it's of opposite sign. So we need to use this idea that we need to resolve one of the bases sign. The first question is, to do this, is negative 4 a even number or an odd number? What is it? Even, right? So basically this will result in negative into negative into negative into negative, that is positive 1 into 10 to the power of 4. Of course you need not write positive 1 and all that, you can just write 10 to the power of 4. Now if you go back to the question, we have negative 10 to the power of negative 4 into 10 to the power of 5, which is nothing but 10 to the power of 4 into 10 to the power of 5, which in turn is nothing but 10 to the power of 4 plus 5, which is 10 to the power of 9. Right, makes sense? Quite simple. Oh sorry, I messed it up. It's negative 4, negative 4. This is 1. 5 minus 4, which is 1. The first note is basis of opposite sign. Again, all these are mental note. You need not write it. So, first we'll try to resolve negative a to the power of negative 5. Right? Negative 5 is an odd number. Odd number. So we have negative a to the power of odd, which is nothing but negative 1 into a to the power of that particular number. Okay? Make sense? Now, all I have to do is copy into that question negative a to the power of negative 5 into a to the power of negative 6, negative 1 into a to the power of negative 5 into a to the power of negative 6, negative 1 into a to the power of negative 5 plus of minus 6 as per your first rule. So we have negative 1 into a to the power of, if I solve it mentally, right, if not I can do it side. So negative 5, positive of negative is negative 6, and the operation is what? Addition. So negative 11. We have a to the power of negative 11. Okay, that's it. The first thing we'll notice is that the bases are of different nature, opposite sign. So there are two options. Either you convert 3 by 4 to negative 3 by 4 or convert negative 3 by 4 to positive 3 by 4 by taking it out, right? So how to do that? First, let's start off with negative 3 by 4 to the power of 10, which is nothing but positive 1 into 3 to the power 3 by 4 to the power of 10. Basically this, right? Because 10 is an even number, and even negative terms being multiplied even number of times will result in positive. Okay, now again negative 3 by 4 to the power of 4 is nothing but positive 3 by 4 to the power of 4. Actually, I feel like I should change this question to negative 4. It will be much useful. So this will be negative 4 and this too will continue to be negative 4. Again, try to understand that these are positive answers because both are even. It's as simple as that. Just look at the power and come to a conclusion. See, having negative powers, it's confusing, I understand. Negative numbers are okay because you kind of getting used to that. It's not too difficult. But negative power, You have to take multiplicative inverse and all of those, but it's kind of confusing, I agree. But as of now, just stick to that. Okay, negative power or positive power doesn't matter. I just have to look at even or odd. So you end up with the answer. First of all, let me write the question. So the next step, I'm substituting 3 by 4 to the power of 6 into 3 by 4 to the power of 10 into 3 by 4 to the power of 4. So all the base are same, and we need to add the powers. So 3 by 4 to the power of, this is 20. That's it. Quite simple, right? Okay, so let's move on. I want to change the next question a bit. This is helpful. Okay, now what are we looking at? Bases are of opposite sign. Base is of opposite sign. So what should I do? Well, let's resolve them individually. Negative 4a to the power of 9. So this is nothing but negative 1 into 4a to the power of 9. Make sense? Negative 4a to the power of negative 6. Right? Here in the first case, I should have explained it a bit detailed manner. This is odd. So negative numbers being multiplied odd number of times will lead to negative. Is it not? So next question, what you're looking at is, next part of the question is even power. So this is positive 1 into 4a to the power of whatever the power is, negative 6. So in place of that, I can write 4a to the power of negative 6 itself. In the next step, we are looking at substituting into the question. So always learn to do this. So all I have to do is substitute negative 4a to the power of 9 as negative 1 into 4a to the power of 9 into 4a to the power of negative 6 whole to the power of negative 6 into 4a whole to the power of 3. I have to keep telling whole actually. If not, this entire thing will be wrong. So now the bases are same. Negative 1, let it be aside. Since the bases are same, all I have to do is 9 plus of negative 6 plus of 3. So I'm sure you guys will be very comfortable doing all of this as of now. So the difference and the addition and everything will lead us to have the answer of 6. Okay, right? So systematically if you do, it will be very simple. It's not too hard, right? As usual, there is few more set of question. Just wait for a minute. Just one last question, not too much. So what we're looking at here is same magnitude but with different signs. So the base are of different sign, right? So we have negative 4a to the power of 9, which is nothing but negative 1 into 4a to the power of 9. Negative 4a to the power of 7, negative 1 into 4a to the power of 7. I did it fast. I hope you guys didn't miss that. All I did was I looked at the power. Both were odd, so the negative will come out as well. The negative terms will multiply to have a negative answer. I just wrote that. So let me write the question first and then substitution. Again, I've seen kids who do all of this, but all of a sudden they start something which no one will understand, you know. Of course, teachers will get to know what the kid is doing, but that's not the way to write anything. And if the teacher is strict, obviously she'll cut marks or he will cut marks. So let us substitute negative 1 into 4a to the power of 9 into negative 1 into 4a to the power of 7 into 4a to the power of negative 10. So first thing first, let's handle the sign. Negative into negative is positive, so I need not write that. And next is 4a to the power of 9. Again, I'm skipping a step. Plus 7 plus of minus 10. Right? You should be able to do all of this. You guys are in higher grade, so you should be able to skip quite a few steps. So 10, 9 and 7 is okay, negative 1, 6. That will be faster actually. I subtracted 10 and 9, so negative 1, 7 minus 1 is 6. That's faster, is it not? So we have, oh yeah, forgot, 4a whole to the power of 6. See, that's the difference. If I had just written 4a to the power of 6, then it's wrong. It's 4a whole to the power of 6.